Hello, welcome back to the playMath tutorial channel. In this lesson we will be looking at matrices. So let's start off with a short definition of matrices. A matrix is a rectangular array of numbers or elements. Let's say elements because it doesn't have to be numbers. So for example, this is a matrix and this also is a matrix. It was the same element. Without taking up any more time, let's go into some examples, and these already are two examples. The first one here is a row matrix. So let me do this a little neater. Row matrix. A row matrix is a matrix. Let me write matrix. A row matrix is a matrix that has its element in only one row. So for example, this is a row matrix and it has elements 1, 2, 4. For a column matrix, the one I did after this earlier, so column matrix would be something like this if I'm using the same elements 1, 2, 4. There are others, but I have to erase so I can show you guys the others. So those two were row and column. Now to the third one, or should I? Let me try and get all of them on the screen at once. So the row matrix, as I said just now, the row matrix is A, let me put a comma, A, B, C, 3 elements. The column matrix would be A, B, C in a column. So they are self-explanatory. A row matrix is only one row, a column matrix is only one column of elements. Next, let me number them. So 1, 2, now 3. A null matrix or a zero matrix. A null matrix or a zero matrix is a matrix with only zeros for elements. So if I have a 3 by 3 matrix with only zeros, it would be considered a null matrix. Or even if I had only a 2 by 2, it would, let me do a 2 by 2 to take up less space. So this is a null matrix. Now onto what is known as a square matrix. A square matrix is a matrix that has the same number of rows as column. So for example, a 2 by 2 matrix would be a square matrix. So this null matrix would be square. Let me do a 3 by 3. So 1, 2, 3, 4, 5, what's that? 5, 6, 7, 8, 9. This matrix here would be a square matrix. Also a 2 by 2 matrix, A, B, C, D, would also be a square matrix. Now to the fifth one, I still have to erase. To the fifth one, a diagonal matrix, and as its name states, you must know that it has some diagonal values, or the element that are not null, they are on what we call the leading diagonal, and the leading diagonal is the first element, then you go diagonally down to the last. So if I have A, I'd have a 0 here, a 0, and for the second row I'd have a 0, then B, 0, then 0, 0, C. And as you see along the diagonal, which we call the leading diagonal, we have A, B, C. That's where we have elements with values. The others are 0 value. Now to a scalar. A scalar is basically a diagonal, except it has the same values. So instead of having A, B, C, I'd have A. Let me write it here if it can. So scalar matrix would have A, A along the leading diagonal. This is 0, 0, 0, 0, 0. So that's what a scalar matrix would look like. The leading diagonal would have values that are equal. So I'd have 3 of the same values. For example, 3 ones. But if I had 3 ones here, it would not just be a scalar, and it would not just be a diagonal matrix. It would be what is known as the unit matrix. And the unit matrix would look something like this. 1, 0, 0, 0, 1, 0, 0, 0, 1. Where we can see the leading diagonal as only 1. And that is known as the unit matrix. Now I must erase to show you guys. I think there's like 4 more, 2 more, or something like that. 4 more. So let's erase and continue. The next one would be what we call an upper. Let me use the black marker as a finer point. So a upper triangular matrix. In this matrix, the values are, let me say, elements that actually have value, that are non-zero. They are after the diagonal, the leading diagonal. Let me show you for example, because it's better to show you. So A, B, C, 0, D, E, 0, 0, F. So what I was trying to say just now, you have the leading diagonal, and everything above the leading diagonal are elements with value, meaning they are non-zero. So the non-zero are beneath the diagonal. And for the lower triangular, let me do that, lower triangular. Your lower triangular matrix would look like this. A, 0, 0, B, C, 0, D, E, F. And again, we see our leading diagonal as values, and then beneath the leading diagonal, that's why it's called lower triangular, and you can see it as a triangular shape for both. So upper triangular, lower triangular. Now for the next two matrices, I have to erase again. So for the next two matrices, we have what is known as a symmetry. A symmetric matrix, just as if I have a equilateral triangle, this is R. Yeah, this is not an equilateral triangle. Let me check. Are not a triangle, but symmetry mean that the same thing on this side is the same thing on that side. That's just a short definition of what symmetry is. So a symmetric matrix then would be a matrix where I transpose. That's a matrix term that I should also let you guys know, but not just yet. But for this example, I will do a short intro to it for this explanation's sake. So you will see this in a book, A transpose. If you have a matrix A, let me write the matrix A first. If you have a matrix A equals, let me do the diagonal first. I have 1, 3, 4, and I have 6, 9, 3, 6, 9, 3. if I have A transpose, if I transpose this matrix, I switch rows for a column. So I write the first row. Let me put this a little better. This is not nice at all. So the 6 should be here, the 9 should be here, and the 3 here. Right. So back to what I was saying. When you transpose a matrix, what you actually do, you change the rows to the column. So I'd write my first row as my first column. So I'd have the 1, 6, 9. Then my second row as my second column. So I'd have 6, 3, 3. Then for my last row, I'd write it as my column. So I'd have 9, 3, 4. So all my rows are changed to column, and that is what we call a symmetric matrix. When you transpose it, your matrix are equal. So my A is equal to my A transpose, and this makes this matrix symmetrical. Now for the last one, we have what we call the asymmetric, which is just the opposite of this, meaning so guys, these are the different types of matrix. In the next video, I will be showing you guys how to add, subtract, multiply, and divide matrix. So that's it for this video. Thank you guys for watching.
Took a swing at a wrecking ball and I prayed for my downfall. And